Hello everyone. Thin layer chromatography, commonly known as TLC, is a simple, rapid, and widely used chromatographic technique for separating and identifying components present in a mixture. It is commonly used in pharmaceutical analysis, research laboratories, chemical analysis, and reaction monitoring. Principle of TLC. The principle of TLC is based on the differential affinity of compound towards two phases, the stationary phase and the mobile phase. The stationary phase is usually a thin layer of silica gel coated onto a plate. The mobile phase is a suitable solvent or solvent mixture that moves through the stationary phase by capillary action. Different compounds interact differently with these two phases. As a result, they travel different distance and become separated. TLC plate and materials. The main materials required for TLC include a TLC plate, a suitable mobile phase, a developing chamber, capillary tubes or syringe for spotting, standard solution, sample solution, and a suitable detection system such as UV light. Preparation of developing chamber. First, the developing chamber is prepared by adding an appropriate mobile phase. The chamber is then closed to allow to atmosphere inside the chamber to become saturated with solvent vapors. Proper chamber saturation helps provide consistent chromatographic development. Sample application. Next, a baseline is carefully marked near the bottom of the TLC plate using a pencil. Small amounts of the standard and sample solutions are then applied as separate spots on the baseline using a capillary tube or syringe. The spots should be small, concentrated, and completely dried before development. Development of TLC plate. The prepared TLC plate is carefully placed inside the developing chamber. The solvent level must remain below the sample spots. The mobile phase then moves upward through the stationary phase by capillary action. As the solvent travels, different components of the sample migrate at different rates, resulting in separation. Once the solvent has traveled an appropriate distance, the plate is removed and the solvent front is immediately marked. Detection of spots. After development, the separated components are detected depending on the nature of the compounds. Spots may be observed directly under ultraviolet light or after treatment with a suitable visualization reagent. Understanding RF value. The movement of a compound on a TLC plate can be expressed using the RF value or retention factor. RF is calculated as the distance traveled by the compound from the origin divided by the distance traveled by the solvent front from the origin. The RF value is unitless and normally lies between 0 and 1 under a given chromatographic condition. Calculation example. For example, if a compound travels 4 centimeters from the origin and the solvent front travels 8 centimeters, the RF value will be 0.50. Interpretation. TLC can be used to compare a sample with a reference standard, monitor chemical reactions, detect impurities, and assess the presence of different components. When comparing compounds, the RF value should always be considered under the same chromatographic conditions because changes in the stationary phase, mobile phase, chamber condition or other parameter can affect migration. Important precautions. For reliable TLC results, several precautions should be followed. Use a clean TLC plate and avoid touching the silica surface. Apply small and well-defined spots. Ensure the solvent level remains below the waistline. Use a suitable and properly prepared mobile phase. Avoid disturbing the developing chamber during development. Mark the solvent front immediately after removing the plate. And always document the chromatogram and relevant experimental conditions. In summary, thin layer chromatography is a simple, fast, and effective technique for separating and evaluating components of a mixture. By understanding the stationary phase, mobile phase, migration behavior, visualization, and RF value, TLC can be used effectively for qualitative analysis and laboratory investigations. If you found this video helpful, don't forget to like, share and subscribe.